Today I would like to go through Azure Application Services, which is an application web hosting service which allows you to host any application in Azure based on Internet Information Server host. And I would like to go through a lab where we will create a new web application. Then we will deploy this application to a newly created Azure Application Service. Then we will create a WebJob, which is a background task which you are able to add to your web application or any application hosted on the original Internet Information Server. These web jobs are in fact console applications which you can use for any background tasks you want to execute within your system. For example, if you want to synchronize any data with the with some ERP systems, or if you want to pick some items from a queue, for example, we will go through a simple scenario where we will pick email messages from an email queue created in Azure SQL database, which is not a really like a real-life scenario where you would better use Azure storage queues for such a queue, but we will get to the Azure storage accounts and queues and tables and stuff like this in later lessons. But for today, I would like to go through application services, web jobs, and Azure SQL. And optionally, we might create an like a mail service, which basically in Azure there is no native service which would allow you to send emails from Azure. There is only one option, which is kind of third-party option offered under Azure umbrella, and you are able to order such service within Azure. It's called SendGrid. It's a separate service, and you can create a free SendGrid account within every single Azure subscription. You can create a free SendGrid account which allows you to send up to 20,000 emails per month. And if you need more, you have to upgrade to a higher pricing tier of this SendGrid service, or use your own SMTP server, or host your SMTP server within a virtual machine in Azure, or whatever else. So to be able to go through the labs I've prepared, I need you to have an active Azure subscription. Do you have one? Yeah. We went through that. You got the promo codes from the SIS, or how it's called. So you were able to create an Azure subscription. Great. All the labs I've prepared, you can find the instructions to go through the labs at, if you go to the web browser and put there bit.ly/ and the code of this course, which should be, I guess, NWSI. Is it correct? 152? It's not NSWI? Just write it, and that's just the shortcut. NSWI152, correct. Which is a link to my GitHub account where I have prepared a Git repository with the solution of the lab. And within the README file there, you can find the instructions to go through the lab. And I will go through the lab with you, and you can either follow me as I will be doing the lab, or you can go on your own, and if you will be quick, you can go through the optional tasks there. If you won't be able to finish the lab within the lesson, then it's expected you to finish the lab on your own. And next lesson we will continue where we will finish today and continue with the next labs, which will probably use the results of the lab we will be doing today. Yes? So the very first scenario, there is a requirement that you should create as a very simple ASP.NET website. Just a question, do you have any experience with .NET platform, C#, Visual Studio? You have Visual Studio on your notebooks, right? And you too. So I'll open a new Visual Studio instance, and I will create a new solution, which is File, New Project, and this can be the simplest one. Is ASP.NET web. Empty website based on C#, this one. I'll call that Cloud Development 3. I can create a Git repository, it doesn't matter. And the intention of this course is really not to teach you how to create a website and how to like code the basic application, but to play with the cloud. So this will be only the simplest possible website to get to the deployment and the options we've got on Azure. Now I will add a new web form. I'll call that default. And in the web form, there should be, I guess there should be a simple label called my label. And in the code behind file, in the code file, I will put some simple code to fill in the label, my label, text equals hello world from Azure. You can test the application locally. Works. But what is the real goal of this lab is to create a new app service in Azure and to deploy the application to this app service. One of the simplest way to create a new app service is to use Visual Studio directly. You can go to Solution Explorer, right-click on your website or application, and there is a Publish Web App item command which you can use. And there is a wizard which will help you to go through all the process with creating the new Azure App Service and publishing the application. So within the first step, you choose Microsoft Azure App Service. And now there is a window where you have to select an existing app service where you want to deploy the application or create a new one. For this lab, we will create a new app service. So with the new button, you get a new dialog where you have to choose an application name, which is the name of the resource created in Azure. This will be the name of the app service created in Azure, and this will be part of the like the basic, like the service URL you will use to access the application. So be careful when selecting the application name, and it has to be unique. So it has to be unique worldwide. So if you hit some existing ID, it will cry. The resource group, as we discussed last week, resource groups are in fact containers or folders where you put your Azure services. So it's kind of a navigational structure to help you organize the services. In this case, we will create a new resource group. It's just the name. For example, this time I will call it Cloud Development 3 RG as a suffix. And the App Service Plan. App Service Plan is in fact the logical virtual machine which hosts your app services. So every single app service has to sit on one of the app service plans you have to create. You can use single app service plan for several app services, and the app service plan is in fact the resource you are paying for in Azure. So the billing procedure is based on the app service plan, and as far as you have enough resources on that app service plan, in fact virtual machine, then you can put in fact as many app services on that plan as you want. So if there is no existing app service plan, if it's a plain or new subscription, you have to create a new app service plan, and you have to choose the location of the app service plan. Usually here we use the West Europe location, which is in fact in Amsterdam. And the size. The size, it's in fact the pricing tier of the app service plan. And it relates to the number of CPU cores and the amount of memory you have available for your applications. And there are two like onboarding or like pricing tiers for the basic playing or testing. It's the free one where there is only very small amount of file storage, like 5 gigs and or 50 megabytes. I'm not sure. Definitely these two services or service tiers are shared. So it's not your dedicated virtual machine hosting those applications. It's shared with other users, and it's like a not performant. So you will hit the performance limits very soon, and you will have to move to the higher pricing tier. But it's you can switch the pricing tier online. So if you want to start with the basic one or the free one or shared one, we can go for that one. And if it's not enough, then you can change your selection later. So for our labs, we will need at least, I guess, at least basic, but I will go for standard, the S version, the P that's for premium, because we want to deploy WebJobs, and the WebJobs are not available in the lowest pricing tiers. So to be safe, I will go for S1, and that should be all. I will create those services. Now it's sending all the instructions to Azure via REST API, and those services are being provisioned, and as far as we get the confirmation, it should be ready within a few seconds. We will continue with the deployment itself. So now what we've got here, the first part of the wizard created like a publishing profile for the deployment itself. And now we will use this profile to deploy the application. All the details, all the technical details like the service endpoint, the site name, username, the password itself, and all these details are already pre-filled. There are like several advanced settings. If you go to the settings section, there is a file publish options where there are 3 additional like switches you can use to fine-tune the deployment. Remove additional files at the destination, which is self-explaining. Whenever you do the deployment, all the excessive files which were, for example, deleted in your project or which were created by your application saved to the file system will be deleted. Precompile during publishing, which means that all the files like C# code and the markup files will be precompiled, and exclude files from app data folder. There is a special app data folder within ASP.NET applications, optional one, which you can use for like storing data which should survive the deployment. So this is like the special one, and you can exclude this folder by using this switch. And one important switch here is that you usually want to deploy like a release configuration, but we don't have a release configuration configured, so I won't struggle with that now. In fact, this publishing wizard, this deployment process, is based on the well-known MS deploy like a utility which can be used for deployment with your on-premises servers or the any other web hosting environment. So it's nothing Azure specific. The last action we have to do is to click the publish button, and now the application is being built locally, and the result of the build is uploaded to Azure to that app service. And as the application will be deployed, we will see the result. So now the deployment is finished, and now it's starting the new app service plan and the application hosted on that app service plan. And within few seconds, we should see our hello world from Azure message. Yeah, that's it.
Can you deploy the database the same way?
Yes. It depends on the setup you want to use for your database. If it's like a local DB database, just the MDF file, you can put that file in the app data folder, and in that case you won't switch the exclude app data folder option, and this way you can deploy the database and use this database like within, it's like embedded SQL mode or whatever it's called. But we will get to the databases later today, and the usual way you use databases on Azure is by creating like a hosted SQL database managed by Azure with full SLA and all that stuff, which is kind of pricey, but you have to take in account that the app service plans you are using for hosting your applications are usually not very performant. You want to use all the power of these machines for the application itself and the database. It's usually better to offload this traffic or this load to the dedicated database service. There are several more options you can use when deploying an application to Azure, app service to Azure. You can use the legacy or traditional FTP access. If you go to Azure portal, portal azure.com, and navigate to your app service. So it should be Cloud Development 3. This is the new resource group I created. And within the resource group, there's a Cloud Development App Service, which is the app service created by Visual Studio on my behalf. And now when you go to deployment credentials, I guess it's the one. Here you can create new deployment credentials for FTP deployment, and then within deployment options, no, it's not the one. It's the, is it in overview? Yeah, it's here. It's the FTP host name or FTPS. You can use FTPS if you wish. And by using this host name and the credentials you create, you can use regular FTP access. There are several more options to automate the deployment. If you go to deployment options, you can choose from several deployment sources where Azure is able to monitor these sources, talk to them, and detect changes. And whenever the source code located within one of these services changes, then there is an automatic deployment process triggered, and the site or whatever it is can be deployed automatically. So, for example, you can use GitHub. I will click GitHub. And if you publish your project to GitHub, it needs your authorization and all this stuff, but I can choose from my projects located in GitHub. For example, this one, it's the cloud development one. Choose the branch I want to deploy and whether I want to run some automatic performance testing before deployment or right after deployment, which is not my case. And if I confirm this setup, Azure will automatically regularly check the state of my repository and will deploy any changes committed to that repository within a few seconds. So you can try this on your own. I already got App Service here. It's called Cloud Development Kit, where I have a deployment configuration from GitHub. And these are the results of previous deployment attempts. So, for example, it was a week ago where I created the site, and today there is a failed deployment, and I can go to the details and see the log of the deployment. For example, here it's telling me that then there is an error in the csprohi file which causes this deployment not being successful. Well, doesn't matter. And the most sophisticated setup is probably related to Visual Studio Team Services. If you use Visual Studio Team Services, which is a cloud version of Team Foundation Server, the Microsoft application lifestyle application lifecycle management server or tool, then you can set up automated deployment within this Visual Studio Team Services account, and there are many more options to fine-tune and do some advanced tasks within the deployment, like transformations of the files and stuff like that. So let me quickly check, but this should be everything I wanted you to go through within the first lab. So were you successful, or do you need any assistance, or do you want to proceed with the next lab? Yeah. Within the next lab, I would like to create a WebJob. So as I told you, WebJobs are in fact simple console applications which you can add to your main application and run these like jobs, like simple background tasks to perform whatever actions you need. You can have, in fact, as many web jobs as you want within a single app service, and for some scenarios you can use, in fact, the setup where the main application will remain empty and you will host only the web jobs within the application. So you can, in fact, deploy the web jobs to an empty app service if you want, and use this app service only to host these web jobs. But in our setup, we will add our web job to the app service we created like a few minutes ago. And as I want you to try the Azure SQL database, we will create an Azure SQL database as well, create a simple table in the database for example, this one will be for emails, like an email queue, and the job will be periodically checking the content of the database, whether there is any unsent email in the table, and if it's found, then it will send the email, which will work like a simple email queue. And as I said, in real scenario, you would better use Azure Storage Queue for this, for the implementation of this queue, but we will get to the Azure Storage later, and we will change this lab to use Azure queues. So the first task is to create a new database and new SQL server. This time we will go to Azure portal. So I will go to portal azure.com. And I will create a resource. The left panel here allows, there is a simple button, create a resource, or you can go to the resource group where you want to create the resource, for example, this Cloud Development 3, and click the add button here, which only pre-fills the forms to put the new resource inside the specific resource group. But we can go from scratch, the create the resource button, and now I will pick the SQL database. There are many services here, but the SQL database is very straightforward here, so I will pick SQL database. And I have to pick database name, Cloud Development DB, Cloud Development, which is already occupied. It's the one we were using for testing, so I will use Cloud Development 3 database. The subscription you want to use, you probably have only one. The resource group you want to use, every single resource have to sit in one resource group, so I will use the Cloud Development 3. And I can leave it blank, or I can let Azure restore data into the database for me, or I can use the AppSvc sample database. In this case, I will use the blank database, and I have to pick an SQL server which will host the database. In fact, it's a logical server, it's not a physical one. So if you create a new server here, it doesn't mean that there is a dedicated server created for you in Azure. It's like a logical container, but for example, the login accounts and stuff like that, it's being shared within that logical SQL server. So I will create a new server. I will call it Cloud Dev 3. Server admin login, it's the SA account, so I'll go for Cloud admin, for example. Password, choose whatever password you want. I will go for a simple one, but you shouldn't. It doesn't allow me to use a simple one, so I will use a password generator here. This one. And the last question is whether I want to use SQL Elastic Pool. The pricing of SQL databases in Azure is based on so-called database transactional units, which is kind of a benchmark, performance benchmark, which says what resource capacity of the SQL server you are buying. So, for example, the pricing tier, the default one, the S3 one, it's 100 DTUs, database transactional units, and 250 gigs storage. And these are the DTUs, it's like a linear scale where you, depending on your workload, you have to buy more and more DTUs for the amount of queries and for the performance you are expecting from the database. The simplest database there is a basic one with 5 DTUs, and it's just for playing. For like a real but simple scenarios, you will need at least S1, S2, there are, I guess, 10 DTUs and I guess 50 DTUs. The important possibility there is to use an Elastic Pool, which allows you to group the performance you are buying and use all the DTUs as shared DTUs for all your databases. So in this basic scenario where you are not using Elastic Pool, you are buying separate performance, separate resources for every single database. And in case of Elastic Pool, you are buying DTUs for several databases, and you can set, for example, the minimum reserved capacity for every single database, the maximum capacity used by every single database within the Elastic Pool. The databases can be added and removed from the pool online. So you can have several databases running outside of the Elastic Pool, and some of the others running within the pool. And it really allows you to play with that, but in general, if you have like more than 10 databases, it's usually more effective to use the Elastic Pool, especially if it's like if it's not the case where you have databases for individual customers, where the customers are paying for dedicated performance, then you would want to have dedicated pricing tier and dedicated resources for them. In usual cases, you can use the Elastic Pool, and it's the benefit there is that it's less expensive. So you usually need less DTUs to fulfill your performance needs than letting your databases run separately. But for now, as I have only one database, I will use separate resources for that without using the Elastic Pool, and I will go for the simplest database. It's the basic with 5 DTUs and 2 gigs of
storage. So as I click create, it needs a few minutes or 1 or 2 to create the database for me. In the meantime, I can proceed with the lab. The usual way you manage Microsoft SQL databases is using Microsoft SQL Management Studio. If you are already familiar with the Microsoft SQL Management Studio, then feel free to use it. The lab is based on Visual Studio, on plain Visual Studio without need to install a separate instance of Microsoft SQL Management Studio. There is a new starting preview, new product, Microsoft product. It's called Microsoft SQL Server Operations Studio, which is a cross-platform, lightweight version of full SQL Server Management Studio. So you can use that for Mac or Linux or other platforms. Today we will use Visual Studio to hit some new like user interface options in Visual Studio. There is a Cloud Explorer. For me, the easiest way to find it is to use the quick. It's called Quick Launch. So I will type Cloud, and it's the first one, Cloud Explorer, which opens the window of Cloud Explorer. And it shows all my subscriptions connected to my Microsoft account. And the last one is the one we are using for this lab. And it lists all the services currently configured or created. And now we want to go to SQL databases. And the one I just created is the Cloud Development 3 database. And I can open the database in SQL Server Object Explorer, which is another tool hosted in Visual Studio, which allows you to browse the database and to perform queries, execute queries against the database. So I can either fill the dialog or use this like a navigational tree. So I'll go for Azure, and this one it's the Cloud Development 3B. And I have to use the password for the Cloud Admin account and connect. The first time you are trying to connect with the database, it's nearly the same if you are using the full SQL Server Management Studio or this Visual Studio. It asks you whether you want to create a new firewall rule in the SQL Server, which allows your specific IP address to connect with the SQL Server. Because the default setup is that the SQL Server is accessible from Azure, from other Azure services, for example, your App Service, but it doesn't accept connections from any other IP address. So we have to add our IP address to the firewall of the SQL Server to be able to work with the SQL Server from our machine. The very same option is available through Azure Portal. If you go to SQL databases, select the database, and there is a
not the database, the server, the database server, which is the SQL servers. This one is the Cloud Dev 3 I've just created. Firewall, virtual networks. And then there is a section called, doesn't have any header. It's the upper section where you create individual rules for IP addresses or ranges of IP addresses where you want your clients to have access to SQL Server. The lower section is dedicated to setting up a virtual network. For example, you can use VPN connection to Azure and access those SQL servers through VPN connection. So I will continue with Visual Studio. I will confirm that I want to create this firewall rule. And now I should be able to connect. So it adds the server to the SQL Server Object Explorer, and I can go and explore the server. There's just a single database there, the Cloud Development 3 database, and I can open a new query window to be able to execute queries against that database. So what we want to create in the database is a simple table for the email queue. I've got the script in the instructions. So it's this one, create table. And it works similar to Microsoft SQL Server Management Studio, so you can run whole query or select part of the query. This time I want to run whole query, so I will click execute, and it will send the SQL commands to the SQL Server and creates the table for me. So we'll get to this database later. I guess it will recover. In real scenarios, you will probably want to create a dedicated service account for your application to access the database on the SQL Server. You usually don't use the system admin account for your applications. Be as secure as possible, so you can use these simple SQL commands to create a new login account within the SQL Server. You have to first create login account. You have to run it in master database, and in the database where you want to log in to have access. You have to create a user with some permissions to the user, usually by adding one of the rules, DB owner or DB data reader, DB data writer, roles like that. We will continue with creation of the WebJob. The WebJob, we will create that as a simple console application within our solution. So I will right-click the solution. It's my Visual Studio currently dying. So So if I want to create a web job, I will have to add new project to my solution, add new project, and this time it will be a console application. So I will go to C# and console application full one. So I'll call that my web job, or it can be email sender, whatever you want. And now I want to create a simple program which will look into database in like a period in time periods and check whether there is an unsent email in the table, and if it's found, it will send the email and it should write the result to the DB and stuff like that. It's currently, the intention here is to show you how to build a web job, not to show you how to do a proper email queue sender. We will get to this probably later, because you would probably want to be able to run several instances of such background job to be able to scale. In that case, you would want to have some type of locking there to prevent single email to be sent by several jobs, and many additional like protections. If there will be any error in the email, you don't want the whole job to fail and stuff like that. But for this specific lab, I will use this very simple code here, which is the main method. And I will have to add some references to the project and some usings to be able to compile. So for example, for the SQL connection, I will have to use system data SQL client for the configuration manager, and we will get to this very quickly. You need to add reference to system configuration DLL. And for the SMTP client, I need system netmail. Net for credentials as well, system net. So this is a very simple procedure. It's encapsulated within an indefinite while loop, which causes the console application to run continuously, and in 30 seconds intervals, or in where there is a 30-second sleep between the attempts to pull data from the database. We are trying to query the database and check whether there is an email to be sent. What are the specifics here? If we want to connect to the database, we have to have a connection string. Usually, if you develop an application which will be hosted in Azure or any other cloud service, or in fact any production environment, you want to use like your dedicated development settings. For example, your development instance of SQL database, development instance of SMTP server, and all this stuff to be able to test the logic, test the application locally, and after all the tests, then you deploy the application to the production environment. It's Azure in our case, and you want the application in production environment to use the production services, production SQL and stuff like that.
This scenario is directly supported in Azure by using application settings overrides in app services. If you go to Azure portal and navigate to any app service, you will notice that there is a application settings section, and in this section there are many detailed switches, and there are application settings and connection strings sections where you can use these to override the values you have in your regular web config file or app config file. So, for example, for the local development, I can have an app config file where I will add the configuration options for and the values I will use for local testing, for local development. These can be, for example, the ones I've prepared for the lab. So in the app config, you would add connection strings section with the connection string to main database, and for the local testing and development, you will use your own local SQL server if it's some shared SQL instance in your development team, or it can be local DB hosted on your computer, whatever you want. And the same applies for the other services or application settings you want to have different in different environments. So in this case, I'm using some virtual SQL development local SQL server and the SMTP host, for example, mail development local, which won't work because I don't have them here. But just to demonstrate the process, how it's working. If you use the configuration manager in WebJobs, and the same applies for your web applications or any other .NET framework applications, then Azure will be able to override the values you have in your config files with the values from the portal. There are several ways this is achieved by Azure infrastructure. For example, for the WebJobs, it's using a dedicated copy of all the files representing the WebJob, and within that copy, it rewrites the config files with the values from the application settings from the portal. For web application, it uses environment variables within the sandbox, which runs the application, and using these environment variables, it injects these settings to your application. But the important thing here is that you have to go to Azure portal, go to the application app service you want to use to host your WebJob, and put your application settings there, the production settings. For the SQL server, you have to use the connection string to Azure SQL database. It's the regular connection string, SQL connection string, like any other. The Azure database has its own URL. It's the name of the server, .database.windows.net.
and you use any additional settings you are using with the connection string. And if you want this demo to work, you have to provide some credentials to any existing SMTP server. And as I said, in Microsoft Azure, the only existing option to send emails is to create a SendGrid account. You do that by, it's the same as the SQL database, you have to create a resource. Here you can use the search, it's called SendGrid. SendGrid email delivery, and it will just ask you to use some name and password which you will use for the SMTP authentication, and you have to put that in a resource group and choose a pricing tier, which there is a free tier with 25,000 emails per month, and then there are two other tiers with 40,000 and 100,000 emails per month. These are like special pricing tiers which were like negotiated by Microsoft with SendGrid, and you are able to buy these directly from Azure. You still can go to SendGrid.com, and then you can change the pricing tier to any other pricing tier they have. You will have to give them your credit card number, and they will charge you directly. But for the basic scenarios, you can use the free account here. I'm not able to continue with this wizard, or it would fail, because there is only one SendGrid account allowed per subscription. So they want to protect themselves. So you are not allowed to create like 100 separate accounts, 25,000 emails each, and to use them cumulatively. The result you get is that it creates, in this case, it will be probably default marketplace apps. The resource group, this is the default one I used years before to create my SendGrid account. And if you go to details, there's the plan, and in properties, it's where are the, this is the key management. Yeah, this is the username and password you will use to authenticate your SMTP clients, your applications, if you want to send emails via the SendGrid account. So in my case, it's the, if I go to App Service, and it's the cloud development app, and I go to application settings, the settings I've created, the SMTP host is the SMTP SendGrid.com. The SMTP username is the one we saw a few seconds ago, and the SMTP password is the one from the same section. And the very last action you have to do is to deploy the whole WebJob to Azure, which is done by using right-click, publish as Azure WebJob, and here you just create a name for the WebJob. You pick whether you want to run the WebJob continuously, which means that whenever the console application ends, Azure starts to start a new instance. So it's like managing the WebJob to run whenever it's possible. And on demand means that you have to run the job manually. It does a few adjustments to your project, but in the end you have to pick the, it's not the one, you have to pick the application service you want to use to host your WebJob. So this is the Hello World from Azure. This is the Hello World application service we created an hour ago, and I will use that to host the WebJob as well. And it doesn't, I have to choose, it's the resource group. Yes, that's it. Okay. And now it creates the publishing profile, very similar to the one we saw when we were publishing the application itself. And now it's the publishing profile for the WebJob. And when I publish the WebJob, it uploads the job to the app service, and it's being started immediately, and it's managed by Azure, and Azure runs that job on your behalf. So it will be probably kind of a homework for you. Try to go through that lab number 2. If you hit or if you meet any struggles or any obstructions, just send me an email, or we can discuss this via Skype or whatever possibility will be right for you. And I will try to help you to go through that lab. Or we can discuss this shortly beginning next lesson. So that's it. Thank you for today.
Thank you.
And see you next week.